Hi, welcome to Chemistry with Miss E. We are going through another introductory topic in your chemistry class that you will be learning, and that is scientific notation. This is when you make really big numbers or really small numbers more approachable, and it's what we mean by that is more condensed basically. So you're always going to have a number that is greater than 0, less than 10, times 10, and then you have an exponent. And so let's do two examples here so I can show you just how easy it is to do. So this number right here, very large, very big, couldn't really comprehend that. Definitely too much time to write this as an answer if that's what you got in chemistry or math for that matter. So let's go ahead and go through the process. You are going to find the decimal. Right now it's obviously at the end of the number because it's, otherwise implied. And then you are going to move your decimal until you get a number that is greater than 0, less than 10, right? So let's say I move the decimal here, right? That would give me 360, not small enough. If I go over again, I would get 36, still not small enough. If I go one more time, I get 3.6. That's the number that is greater than 0, less than 10. So that's going to be my base. So 3.6. Now, you always include this times 10 part. That is the form of scientific notation. And what's my exponent? Your exponent is however many times you have to move your decimal to make that number that you just created. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I move my decimal 9 times in order to create 3.6. So 3.6 times 10 to the 9th power would be my answer in scientific notation. Let's do another one. This is a very small number, right? If I have 0.000000412 cookies, that's like a crumb of a cookie, right? That's a very tiny number. And so we're going to create that and turn it into scientific notation as well. This time, though, I need to move my decimal this way, right? Because that's where the numbers are that are greater than 0 and less than 10. So if I move it 1, 2, 3, 4, 5, 6 times, I have 0.4, not big enough. If I move it again, I get 4.12. That's a number that is greater than 0 and less than 10. So 4.12 times 10, and then my power is going to be however many times I move that decimal to make this number. I moved it, we'll count again, 1, 2, 3, 4, 5, 6, 7 times. It is going to be a -7 because I moved my decimal to the right. In other words, I like to tell my students, if you had 0.000000412 cookies, do you have 4.12 cookies? Absolutely not. So we're making a number that's very small and saying that we technically as a base have 4.12 of it. That's going to be a negative exponent because there's matter there, right? That doesn't actually exist, if that makes sense. So negative exponents when you're working with really tiny numbers that are less than 0, okay? One other thing that I want to mention, because you will be using graphing calculators or a calculator of some sort, and you will be getting an answer in the calculator that has an exponent. But let's look at the format for that. Let's say that I put in 6.52 times 10 to the 54th power. What do you notice here? It tells me 6.52, the zeros, which are irrelevant for right now, E54. And so do not write this as your answer. Do not say E54. You need to know what that means. E54 means times 10, and E stands for exponent. So that means the 54 is your exponent. So you are actually going to write 6.52 times 10 to the 54 power, okay? Let's try it for a negative exponent, 5.45 times 10 to the -4. Again, it's going to be 5.45 E, which means times 10, -4. You can see it gives you the negative there. All right, like, follow, subscribe if this was helpful for you. I'll see you on the next one.